Hello. Hi, welcome to the Moses webinar, Moses Live Lab. I'm Marcus. I'm field support engineer for Moses. When I'm not grounded, I travel the world and install our systems. Yeah, welcome to our first webinar. It's a series of webinars. We lined up a couple over the next few months. It's basically to show you what we've been up to in the last couple of months. So we bring the trade show to you because you can't go to the trade show. So the webinar, just a few, a bit of housekeeping at the top. The webinar is going to be 60 minutes long. We have 40 minutes for the presentation and then a chunk of 20 minutes for the Q&A. The Q&A, I would ask you if you have any questions regarding the presentation, please use the Q&A feature of Zoom and don't use the chat. So down there somewhere you should have a button called Q&A. So you just click on it and then you type it. You can do it anonymously so we don't see your name. Also, the webinar will be recorded, so you get a link in like a couple of days if you want to rewatch it or you want to share it with someone. Okay, so as I said, it's our first webinar and we have like a very special treat for our first webinar. We're going to talk about a very exciting collaboration between Moses and Panasonic. So we partnered up with Panasonic, who created the AWUE150 head, and we enhanced it with a Star Tracker module. I don't want to give away too much, but yeah, the speakers for this afternoon or morning, if you join us in America, will be Michael Geisler, the CEO of Moses. We're also going to be joined by Jaume Miró. He is project manager from Panasonic. And we also have Martin Parsley, who's going to talk about Star Tracker, the technology behind it. And we have Gary Atanasio, who is business developer and sales for the Americas. Okay, so I think we should first go to the Moses studio where I welcome Michael and Ben.
Hello. Hello, everybody. So don't worry, I think there's enough distance. Welcome in the Moses studio, and we will show you our newly Star Tracker enhanced UE150. A little bit about Moses. Moses has been in the film industry for quite some years, and we started off with robotics, and then went into the broadcast industry with some tracking. Here we see a slide of, there actually has been quite a lot of feature films shot on our robotics and remote heads. I think we have about 25 systems just in Hollywood on its own. And that forced us to listen to what people need on the ground in sort of operating equipment for remote heads. And as a result of some pretty big movies since then, everybody may know Gravity, where we actually were involved in every single shot with our lens and the camera control technology. Interesting was at that time, we were involved in one of the early usages of LED screens. I think they're sort of starting to flourish now as well. No, and then we went in the broadcast industry with our robotics and with tracking, camera tracking, by connecting encoders to cranes. I think that was back just like in 2002. And then we thought there must be a better way of tracking, and then we started to develop the Star Tracker. But I think Martin will explain to you more about that in a little while. As a company, we then, in the robotics, it looks like now there is quite a lot of revival happening concerning the coronavirus, and the whole film industry is thinking about how can we actually produce films in a sort of social distance way. And it looks like we're going to see quite a lot of remote heads on film sets as well in studios. And for broadcast studios, we're also having another solution coming up to overcome COVID issues, which is, we call it TimeCam. We will launch it soon, but it helps you basically from, let's say, one continent to operate the camera on another continent without apparent delay of time. So you're able to follow, let's say, a Formula One car from another continent and without a delay. But we will explain about that in another webinar.
Fantastic. Sounds very exciting. I think it's time to introduce Jaume from Panasonic. Jaume, can you hear us?
Yeah, hello.
Hello, how are you?
Fine, here in Barcelona, confined as well, as you.
First of all, congratulations, you revealed you had yourself yesterday.
Yeah. Yes, yesterday we announced during our NAB virtual event some exciting new products for this year, and one of them was a new PTZ camera, which is a small sister of the camera that we are going to talk today. So the new camera is the UE100. Today we will talk about the UE150, which will remain to be the high-end PTZ for us. But yeah, everything that we say today for the UE150 in collaboration with Moses and Star Tracker will be also valid for the new camera when it comes around September time, more or less. So yeah, in September there will be probably two options, so more choice for the customers. Yeah.
Okay, that sounds good. But today we're going to talk about the UE150. Yeah, Jaume, if you could just give us like a brief introduction to the head.
Yeah, so the UE150 was the first PTZ camera that provides tracking data. It means that the camera provides its position, pan, tilt, zoom, focus, iris in sync with a Genlock signal. So the camera all the time provides that information that is needed for any AR, VR application. It does in a protocol which is kind of a standard, which is the 3D or D1, also both names. So we support that protocol over serial or over IP. Both connections are available. So it means that the camera is directly compatible with most 3D engines in the market, but also we take that functionality to have a compatibility with tracking systems like the one that you are presenting today. So for UE150, I think it's getting a quite popular camera for these applications, but just let me say some highlights of this camera. We are talking about a 4K PTZ camera supporting 50p, so perfectly usable for broadcast applications. It supports also other frame rates, more cinematic and so on, but it's perfectly fine for 4K broadcast. It has a good balance in the lens. I mean, it has a good zoom. It's a 20 times optical zoom, but at the same time, we have a wider angle of view, which has been a request from many customers during these years. So the camera can fit into very small spaces, small studios, for example. No need to think in wide angle converters for the camera. So it's really wide. So it's a good solution also for small environments. The camera is 4K, but it's easy to work in HD or simultaneously 4K and HD. So the camera offers a lot of possibilities with simultaneous outputs. And for example, so the camera supports HDR, and you can have HDR in some outputs and SDR in others. So it's really flexible in that sense. The camera supports also the logarithmic curve that in Panasonic we call VLOC, which, for example, that's good, for example, for some 3D engines to improve the keyer, the rendering. Okay, so that's a nice function as well. And of course, we are talking about a PTZ camera, so it means that it's an all-in-one camera. So it means that the lens is the same for all the units. So it allows to create a calibration file. So you can find this file is provided by the 3D engines in the market. So you can just load this file, and let's say the calibration of the camera is a matter of minutes. You don't have to spend a lot of time for every camera. So if we go, I'd say, yeah, it's easy to calibrate the camera. That's fine. It means we save a lot of time, a lot of headaches for that. But take a look, for example, at this picture in a program in a French broadcaster. The camera is sitting on a flight case. So okay, it's there, it's calibrated. But what happens if somebody moves that flight case or moves the camera, even accidentally? It means that we lose our calibration, right? So even by accident, we can have such kind of problem. So it means, okay, please call somebody to recalibrate the camera again. So things like that can be avoided by adding a camera tracking system. Like I think Moses are experts in that sense. So it means that you have freedom of movement, so you can move the camera around. The camera is all the time calibrated in the space. So we don't have to worry anymore about a tripod being moved or a camera being accidentally touched. So peace of mind in that sense. But at the same time, this possibility of moving the camera around gives a lot of possibilities from a creative point of view. So we can really create beautiful pictures, and as we will see later on in the studio today. So this is not the first collaboration with Moses. Maybe for some people in this call, they may remember. I do remember, because it was my time joining Panasonic, this kind of solutions. We are talking about more than 16 years ago. So Panasonic had a lineup of pan-tilt heads, and there were external solutions at that time. One was from Moses already at that time, to make our pan-tilts compatible with AR VR systems. So what at that moment, so it was an external solution. Now it has become an integrated solution. So now the tracking comes from inside the camera, and as we will see, we add the tracking externally to combine both data. But I think it's a huge advance in that sense.
Yes. So shall we reveal the new head with the Star Tracker module?
Yeah.
Yep.
So
okay,
let's unveil a surprise.
There it is.
Here it is. So yeah, it looks nice. It matches perfectly the base of the camera, as you can see. So it's perfectly integrated with the camera. Is made for that PTZ. So yeah, I think the picture speaks by itself.
Okay, thank you very much for that. So now we know the star tracker is going to help us with the positioning of the head, but we don't know exactly how the star tracker works. And for that, I'm going to introduce Morten Parsley. He is the star tracker lead developer from Moses, and he's going to tell us a bit more about how star tracker works. Hello, Morten, are you there?
Yes, I am. Hi, Marcus.
Oh, Morten, can you switch on your camera?
It says it's disabled. It's probably, so it says host is disabled. Start your video. Must have been me.
Oh, here we go.
Can you tell it's my first webinar? It was also really cool to see the earlier Panasonic head, the first generation. That was even before my time. But without much ado, so the star trackers, hopefully some of you have used it and heard of it, and some of you listening in, maybe it's your first time hearing about it. But the star tracker is a real-time optical camera tracking system that we developed around 8 years ago, and we developed it specifically for this industry, for broadcast and film, for tracking cameras. Now, tracking in this industry is probably one of the most difficult use cases one could think of, because you have a need for a high degree of accuracy in the kind of on the kind of large scales, such as 10-meter high studios. At the same time, you have all this chaos going on, lighting and so forth. So we had, when we came up with the star tracker, it is an optical tracking system. However, in order to give it that extra robustness, our special concept, which we patented around 8 years ago now, I think, is we're going to track from an artificial star map. So the star tracker is going to ignore all the other chaos going on in the image, and it's just going to track off these small, what we call stars, like tracking from a real star map. So what you do is you take these small, cheap, identical, random retroreflective stickers, and you just stick them up randomly all over your ceiling. You can do it at multiple heights on any structures that aren't going to move. You can put it above the on the ceiling, above the grid. You can put it on the grid. It's all fine. And then from what you do is you have a one-time calibration process, one time only. You walk around with a star tracker sensor, and it will automatically pick up the 3D positions of the stars and kind of build this internal star map, which it saves. And from then on, it becomes automatic and easy. So you go into the studio in the morning, you turn on the system, it automatically figures out where it is by the kind of constellation of these stars, and then it starts tracking automatically. So when this came out in the intervening years, it's really taken over the industry by storm. It was quite a game changer. We now have users, big name broadcasters using it, such as Sky, NEP, ABC, BBC, ESPN, the Weather Channel. They're all using this in this use case. And we think that's because we have a really unrivaled balance of ease of use and flexibility, whilst also meeting the requirements of accuracy, robustness, and scale. So for ease of use and flexibility, what we mean is because the star tracker attaches to the camera, you have complete freedom of movement. So you can place it on the end of a jib, like this is from the Sky election coverage last year. So we have a star tracker on the end of a, oh no, this was in the base, on the base of a techno crane. You could also put it on the end of a techno crane, also on a pedestal, on a Steadicam, which we did for the recent Brit Awards, which is really cool, if some of you saw that. So this ease of use and flexibility, the way it tracks just automatically, and it becomes something you just set it up once and then you forget about it. That was really important. Your cameramen don't want to be having to twiddle knobs and levers to deal with a tracking system. They want to forget about, they want to forget that it's there. It just works in the background, and you just concentrate on framing your shots and operating the camera. The kind of robustness to occlusions, lighting, set changes, running in plain green screen environments, running live on air, it's no problem for the star tracker. That's what it was designed for, and it does it very well. So what do we have here? Let's see. So we have the star tracker components. So the standard star tracker is very general. So you can mount it to pretty much any camera and it will work fine. But as you can see here, there's lots of components. You have to take the sensor unit and mount that. You have some cables, like you may be having external lens encoders. You have to supply power and take the tracking out and provide gen knock all the way down. If you also had a Panasonic head, you don't want to be doing that twice. So that's motivated us to specifically make a system, a star tracker module, that's designed to work seamlessly with the Panasonic head. And that makes it, that retains that ease of use. So you're not dealing with two separate systems and you somehow have to cobble together the data coming through. The two are designed to work. So what we have is simply a module there. The processing is on there. The star tracker unit is, as you can see, the sensor is integrated there. The fact that there's a PTZ behind it doesn't matter. It's robust to that kind of occlusion. And what happens now is the star tracker is responsible, as far as tracking goes, for getting the data to the virtual engine. So it's no longer the case that you have a star tracker and a PTZ head giving independent data to the engine and you have to somehow cobble it together. The PTZ head gives its pan and tilt data and the zoom and focus data. Those come out of the back of the unit and go into the star tracker. And the star tracker is in real time computing the XYZ, pan, tilt and roll position of the base. And the star tracker takes in the pan and tilt data and the lens data, fuses it with its estimate of the base and gives out tracking data in either Moses F4 protocol or D1 protocol. And it's the data that you get is at the camera, not on the base, for instance. So you don't have to do anything more. You get the CCD position, as it were. So that's retained the simplicity and ease of use. It would be nice to go over to the studio now, I think, and show you some of the properties of the star tracker, such as the occlusion, basically the robustness.
Let's just go to the studio.
Yep, let's have a look. And here's Marcus joining us in the studio. Hi, Marcus. So Marcus is standing here with our standard star tracker, and there's the sensor unit on the top, which he's pointing to now. There we go. And you can see the tracking, the kind of constellation of stars in the bottom right of the image. And then first, Marcus is going to show you the robustness to occlusion. So let's say something is going over the sensor, you can see optical good. Because it's tracking off these very small discrete reflectors, you can actually cover a lot of you can actually cover a fair amount of the camera. And as you can see, it will still see enough stars in the periphery to be able to track. The next thing Marcus will show is, of course, robustness to light. It wouldn't be a very good broadcasting film tracking system if it wasn't robust to light. So he's going to turn on this powerful halogen spotlight, and you can see from the bottom that it almost doesn't really appear like a spotlight at all to the star tracker. It's just another object on top of the frame, and it's still happily tracking away. And then the next thing Marcus will show you is tilt. So this is what we mean by freedom of movement. So you can see he's tilting, he's gone over 15 degrees, he's probably now at 45 degrees. And as long as the system can still see stars, it's happy to keep tracking. So it's not going to put constraints on kind of your usage of the system. You don't have to stay upright or otherwise. You can use it handheld and so on. And it's only now, he's practically going to 90 degrees and only now is it starting to complain. And of course the system has a gyro as well. So even if you do lose tracking, you will still have your angles, pan, tilt and roll to go on. And then it automatically finds where it is again when you come back up again. One thing that would be interesting to point out is the star tracker technology is what you call an inside-out system. So what, as opposed to outside-in system. So an inside-out system is where we put the tracking sensor onto the object, such as the camera, and then you have the reflectors in the environment. An outside-in system is like similar to a traditional mocap system. So you have tracking cameras dotted around the studio, and then you have reflectors on the camera. We believe that the inside-out system is better. We think it's more cost-effective because, of course, you only need one tracking camera. It also means it's easier to work with because your lighting people, for instance, don't have to worry about having, are they going to interfere with the tracking cameras if they move the lights around? You don't have to worry so much about occlusion from set pieces. And so for that reason, we think that the inside out Star Tracker system is more natural for tracking cameras. Okay, I think now we'll go back to, is it Jomar? I think we'll go back to now.
Yes, I think we're going back to Jomar. Jomar, can you talk a bit more about the integration of Star Tracker?
Yeah, so the thing is, at the end, what is the application of adding the Star Tracker to the camera? So I think at the end is basically the possibility to move the camera around. And by this, you can create better pictures, engaging content, attractive images for your production. So this possibility of moving the camera around in additional axes, for example, putting the camera on a jeep or on a crane, this creates something that you cannot create just by pan tilt movement on when the camera is on the tripod. So now, for example, putting this camera on a jeep, as we are going to see now in the studio, something that until now maybe was a bit strange. Why to put a PTZ on a jeep? So as you will see now, I think it makes sense because the movement, the pictures that you create by doing that, it has nothing to do with when the camera is sitting on a tripod. So it means better pictures, but at the same time, this freedom of movement, this peace of mind, because the camera is calibrated all the time. Forget about this maintenance thing. So you can put the camera, take it out, put it again another day, and the calibration is if needed, is just a matter of minutes. So no need to ask a technician to come and please recalibrate my camera again. No, it's all time calibrated in my studio. So it brings a lot of possibilities, especially from the picture creation point of view, as I hope you will enjoy now in the studio.
Yeah, so now we're here in the studio for a live presentation of the head. Guys, take it away.
Hi everybody, welcome in our MoSys studio, and here we see the Panasonic UE150 with the Star Tracker. And we talked a lot about Star Tracker and its strengths and the strength of the UE150, and just want to demonstrate this to you, what it actually does and what it means if you suddenly start moving the camera. Okay, Marcus, can we see the AR? So this is the operation of a normal remote head. So normal remote head will just go left and right, but it's just panning basically within a picture. It doesn't give you a feeling of actually being in the room and in the space, but only when we move the head, that's when we can do that. I'll show you that. I just release the brake here, and that one here. And now let's go sideways. Now you suddenly have a feeling for the space. You're in that space. And that makes the difference when you move a head around. And the moment you have a feeling for the space, you pull your viewers into the space and you experience the three-dimensionality. And for this, you need a parallax, change in parallax that you don't have if a head is just on a tripod. And this is now enabled through the combination with the Star Tracker. And the Star Tracker is, it's that easy. It's an absolute system. So wherever you have that in the studio, you just switch on and it will work. It also goes wall to wall. So there is no hotspot in the middle of the room where it works, and towards the wall, it doesn't work anymore. So, which means you can use smaller studios. I mean, like ours here, and you go wall to wall. So in order, so you can achieve those movements on any, let's say, dolly rail system, and you operate it from your from a Panasonic desk with your joystick. But what we also now did, we developed input devices or an interface to input devices that you can operate that on a crane, like I'm demonstrating here. So these are ordinary Jimmy Jip input devices. You have a focus and a zoom on one side, and you have the pan and tilt on the other. So a single person can operate the crane as well as the head and the lens. So you can achieve those movements with just one single operator. And we have achieved that by introducing our control box that is talking then from the input devices to the UE150. At any time, you can override those signals from your control room, and the control room will then take over the motion from there. So you can operate from the studio as well as from the control room. There's also another way to move the head, and that is actually by using face recognition. I demonstrate that to you. So I'm walking along, and the head will automatically follow me. I only find out today that it also works actually if you show your back to the head, and it still follows. It's quite impressive. It's very, very robust. It also can differentiate between different people. Marcus, could you walk through frame? And I will now go the other way. And let's have a look what it's saying. Oh, no. Okay, I think that's an exception. It was working differently before. Okay. But it's back on me. Thank you very much. So I want to sum up. There are basically three main points that sort of bring your three main points that are the strength of this combination. And that is, first of all, accidental usage or kicking of a tripod or whatever support there is, and you suddenly find your virtual studio out of line with your real world. The second is it giving you the freedom to place your tripod or whatever your support is anywhere in the studio and change the location of the head. And the third thing is the creativity. You can actually draw viewers in by having lateral moves, linear moves within the environment and creating a much higher production value. So.
Okay, thank you very much. That was very impressive. Thanks to the guys in the studio for setting it up. It looked amazing. Yeah, I think we should maybe introduce Gary at this point because he hasn't seen the head in action yet. So it's also for him a completely new experience. Gary, are you there?
here.
Hey, Gary, how's it
Hey,
going?
guys.
So it's the first time you saw the head. What do you think?
Most impressive. I really like the way that it shows once you introduce parallax, how dynamic and immersive it gets.
Do you think there's like a market for it in the US?
Let's see. I'm in sales. Of course I do. Of course I do. We're getting tons of questions now. One of them is from our Colombian dealer, AT Medios, asking when this will be available.
That is a
Now.
good question.
It is now available. I think we have a lead time about 4 weeks.
Excellent. Very impressive, guys. Also, I was asked what the delay is.
It is a star tracker. We're actually fusing, there's tracking data coming out of the URI 150. We're taking that in and fusing that information in the star tracker. Martin, does that add a little bit of delay? Martin?
Sorry, I muted myself there.
Yes.
Okay. I think there could be one. I think the overall delay is around 2 fields, which should be quite, which is probably
acceptable.
not so noticeable.
That's quite acceptable.
Yeah.
Another question that's been asked several times is, does this interface with Disguise?
Yes, it absolutely interfaces. So we have an interface with Disguise, which is our F4. It will interface to that. Now, another question is how to operate it, but we demonstrated several ways of doing that.
Mm-hmm.
Yeah. So there's another question from Toby. He wants to know, does the camera have to be used in desktop mode, or is there a hanging version on this one?
You can hang this whole thing upside down, and actually also you could have it upright as we have it now, and take the tracking from the floor. So you can turn the Moses star tracker around, and it will face out downwards, and it will also track there.
Yeah.
And on the floor we have all sorts of color stickers. Basically, it needs to be retroreflective. Those stickers, this is what you could scrape off any ambulance or police car. Don't do that, but it's the same material, and it comes in all sorts of colors, including black. And if you have a totally black, shiny floor, it works perfect on that. The silver ones are the strongest. That's why we prefer them actually for the ceiling. But yes, you can also work with upside down, and you can also turn the head upside down.
Okay. Jaume, there was a lot of interest for the new head, and the question was, is it compatible with the star tracker?
It will be. We have just announced yesterday, so the camera will not be on the market until September. So yeah, in the coming weeks we will start with some samples, and yeah, but the in terms of protocol and communication is same. I mean, for all the things that we have seen, it's just the camera is a bit smaller, so it needs to be adapted a bit mechanically to the star tracker, but this is not going to be an issue. So the protocol is the same. We can use exactly as we have seen for the 150. So yeah, both cameras are going to be compatible with that application. Yeah.
Very good. There's a question from Michael. Can we use this device with and without star tracker if we unplug the cable from the back end? I think he wants to know how easy it is to switch between just using PTZ or in combination with star tracker.
No problem. Just unplug it. It will stream its normal Radarmec protocol out of its back, and if you plug that into, I mean, you may require some rearranging settings at your render engine. But from the hardware itself, there's no problem. It will just, no, and there is a difference because we're fusing the Radamec protocol that is coming out of the head into our F4 protocol.
Mm-hmm.
So there will be different outputs.
Okay.
So from the combined solution will be F4, while if it's just the head, it will be Radamec.
Okay. Another question is, will the infrared sensor interfere with the camera?
Not at all. We specially sort of sloped it down so that even if you angle all the way down, it sort of is not in your face or not in view. And the infrared doesn't interfere with the lens optically at all.
Mm-hmm.
Marcus, are there more questions?
Marcus, for those who have missed this and would like to see it, how easily can they access this recorded presentation? All right, Michael, can you answer that?
It will be online, or we're definitely going to provide links for that in the next few days.
Great, thank you.
Or hours, I don't know how complex this is. This is the first time we're doing this. So it will be online, accessible. We're creating a little library of what we do, and there's a hell of a lot coming in the future. We are working on a lot on sort of having these webinars will give us the possibilities so basically to bring this to the outside world.
Currently. So there have been. Oh, but there have been a few questions coming in. So I'll turn my attention to some of those. Somebody's asking, can I share an existing star map? So if somebody already has a star tracker, can they share that map with the Panasonic enhanced, or should I say the star tracker enhanced Panasonic head? Yes, you can. The maps are completely compatible. So you don't even have to do mapping if you already have a studio with a map. Some are also asking about whether we support particular render engines, and we are more or less render engine agnostic in the sense that we can send out our F4 protocol, and most, if not all, the main engines support that protocol. We can also send out D1 for some that don't, and it will just work completely with all those render engines. So there's no specific virtual set software or render engine. Somebody is also asking, Fred, you already have a star tracker to track the Steadicam, and he's wondering how this camera could work with a Steadicam. So I presume if you want to have a lightweight, maybe a lightweight Panasonic head on the Steadicam, that seems like an intriguing solution. From the technical tracking end, yes, you could. You could put the Star Tracker enhanced Panasonic head onto a kind of Steadicam and wander around with that. You will get the correct XYZ and pan tilt roll. So even if you roll the base and pan the head, you should still get the correct position in 3D space, as it were. So that's intriguing. It would be intriguing to see.
Intriguing use case. I mean, we thought we sort of pushing boundaries by putting the Panasonic UE150 on a crane. Wow, Steadicam is the
I
next
think
step.
that'd be
Fantastic.
very cool. Who would be controlling? I wonder, would the head be left to look around by itself, or would somebody, would the focus puller now also become the pan and tilter? Or I'd be very, very curious. Somebody was also asking, how long does the system take to set up? So one thing I'd say about the setup is some of you are already familiar with our Star Tracker setup for the standard Star Tracker, which is the so-called auto aligner, or also the drop OXY method. And the Panasonic does support both. So that means you can use the auto aligner. So you put the jib in various positions and you can pan and tilt the Panasonic head, and it will still give you a correct good auto align through that method. Or you could also take the base and place that on in your several positions to do your setup. So hopefully that should retain the basic simplicity of setup. And I think in terms of the setup and the tools we have for that, that would be a good topic for another webinar on where we show how you set up a system like the Star Tracker and reference it to the real world. See what else we have. Intuitive setup, sure. Star Tracker. The face recognition item is actually a part of the Panasonic head, if I'm correct in that. So you get that with the UE150 inside there rather than the Star Tracker.
It's a piece of software that we install in a Windows PC. So it works with any Panasonic PTZ, but it's a software application and it's using only motion detection. So there is no need for sensors or something in the presenter. So it's just purely image analysis. And yeah, it's a piece of software that you can just run on a PC. Now we are offering 90 days trial. So I invite anybody to download and it has 3 months to test that software with any PTZ, not only with a 150. So you can install and test it right away.
So this is an option or standard equipment?
No, it's an option. So it's a one-time purchase for the software. So there is different versions. There is a standard version. It's also for multiple cameras. We have a server version, and then we have also the number of licenses depending on the number of cameras that you want to control simultaneously. But yeah, it's kind of accessory. So yeah, we give this a 3 months trial. After that, you would need a license. Yeah.
Okay, so you would have free use of it, try and buy kind of thing for 3 months.
Yeah.
Is there a published price yet?
Yeah, I mean the software it's nothing new. I mean that's why now the performance is quite good, because it has been there has been several versions upgrades. Yeah, it's around 1,000 euro or dollars approximately the license, roughly. I mean, but it's around that. It's one-time purchase, so you purchase only once, and there's no subscriptions and things like that.
Excellent. I think everybody will want that.
It's a fantastic add-on. It really
absolutely.
One question. Yeah. One question that came in was asking about regarding the face tracking functionality. Does it add extra tracking delay? And I understand that there's no extra tracking delay when using the face tracker. Is that correct for the system to?
No,
it shouldn't.
No,
I mean,
no,
I guess it's totally separate functionality.
And there was also a question regarding what frame rate does the Panasonic head support? What range of frame rates?
So in Europe it's 50p or 25p. So you can use also for cinema applications. In America, it's also 60 hertz, 30 and 24p as well. So, yeah, I mean.
And James mentioned a 23976 mode. Is that I guess that's a drop frame mode. 24 drop frame.
I think it's 2398.
Okay.
Let me check.
Are there any more questions?
There was some, so we have some questions. So Suresh was asking whether it's compatible with, I think, is it the stage precision system, but I'm not familiar with that. But in terms of the tracking, we can interface pretty much to any system, any rendering system. And anybody who, if somebody does have a rendering system that they'd like to interface with Moses, then please get in touch with us and we can help with that. As for the official release date, I guess it's ready now to answer James's question. And to answer Ruben's question, does Moses spit out any other protocols other than 3D? Yes, so Moses F4 or Radimec D1, but our Moses F4 protocol has it's got more capabilities than 3D, which is a fixed length protocol. We also have some questions regarding the developments regarding additional operator controls specific to virtual production. So somebody has asked, for instance, can you discuss accompanying hardware developments for additional operator controls that are specific to virtual production? Such as mapping to Unreal Engine for blueprints, follow focus. Is that one for you, Jomar?
I think that's better if I answer that. So is that concerning input devices directly to the Unreal Engine? To basically move virtual worlds?
Yes. Okay, yes. Somebody else is asking, are there controls for the PTZ head built into, for instance, Unreal? How would they control the head from the Unreal Engine, for instance? But maybe you could discuss sort of the possibilities for software and hardware operator controls. I guess we've already shown our Jimmy Jib joystick controls, which are pretty much industry standard.
Are there any more questions, or should we call this an end?
Somebody's asking, do you have any reference for Star Tracker in UAE, in the Middle East area? So Prakesh, if you get in touch with Ben, then I'm sure he'll be able to supply you with references. Can I synchronize the control of multiple UE150 heads to track the same shots? I'm not sure, can we?
Sorry, is that like motion control?
It sounds like it. Synchronize the control of multiple heads. I'm not sure.
We probably could help on that.
It seems, I guess, not out of the box, but it's something that, something who can help you.
Talk to us.
Exactly.
So, Martin, you were asking or reading a question about references. Can I give this to Gary? Gary, what sort of references do we have in the States?
That are currently using Star Tracker?
Currently using Star Tracker.
Well, ESPN have, I don't know how many, they have,
I think 21.
double digits, well into the double digits. We have ABC Network. We have ESPN Brazil. We have, of course, the Weather Channel, CNN, Turner Studios, Fox Sports South in Atlanta, Atlanta North studios. We've got a couple of Hearst group stations, Scripps, Univision, Telemundo. We've got a nice feed there.
So we pretty much have them all around the world. So Prakash is specifically asking around the United Arab Emirates area, but I'm sure we have some too, or
yeah, so why am I answering?
From.
Okay.
This one sounds similar to USA, but we're active around the world, basically. So talk to us and get in touch, basically.
So ben@mosis.com.
Or just follow the info link. That will work as well. Good. So I would like to thank everybody for joining us on this webinar. It is our first, and I think we're quite chuffed. We're going to do more of that. I'm sure we will improve as well. It is a first, and I really want to thank you, everybody here at Moses and helping. I want to thank Xiaoma, and I'm looking forward to a really good relationship to work together and maybe create more cool and very useful instruments to bring higher production value to our users. And our users and whoever was watching, please thank you very much for doing so. Get in touch with us. We're a company around 40 people, but we're quite agile. We listen, we can adapt. We're quite good at that. Please get in touch with us. Thank you very much for joining us for this webinar. Thank you.
Thank you, everyone.